divide A, 15.7 divided by 4, B, 1.452 divided by 24, C, 56 divided by 32, and D, 0.2 divided by 30. We're going to do 4 decimal long division problems here. Notice that I've drawn some vertical lines on the whiteboard. The vertical lines will help me keep my columns lined up as I go through the calculation. You might want to do the same sort of thing. In fact, you could take a sheet of binder paper, just turn it sideways so that the blue lines go up and down. And you can use those blue lines to help you keep your columns lined up as you work through similar problems. Now, let's go ahead and set up the first long division problem. A here, 15.7 divided by 4. 15.7 goes inside the long division box. I write 1 in a column, 5 in a different column. The decimal point I'm going to write right on top of one of my red lines. And then the 7. There's 15.7 inside the long division box. Out front goes the 4. Remember, the long division process involves repeating a series of steps over and over again. I call those steps divide into, multiply, subtract, and bring down. Now, before we get started on our problem here, I want to think about the location of the decimal point. The decimal point inside the long division box is right here. The decimal point in our final answer will be located directly above the decimal point that's inside the long division box. So I can go ahead and place my decimal point in the answer right now before we begin. Now let's go ahead and start the process. I start out by thinking about how many times the number in front, the 4, goes into just the first digit, the 1. 4 doesn't go into 1, so I'm going to look at the first 2 digits, 15. How many times does 4 go into 15? Well, 4 goes into 15 3 times, so I write the 3 above the 5. 3 times 4, that's my multiply step. 3 times 4 is 12. And then I go ahead and subtract. 15 minus 12 is 3. Notice before we go further that because the 5 is just to the left of the decimal point, the 3 in the answer is just to the left of the decimal point also. Now we just completed our subtract step. After subtracting comes the bring down step. So I bring down the next digit. I bring down that 7. And then I go back up to the first step, my divide into step. How many times does 4 go into what I now have here is 37? 4 goes into 37. Let's think about that. 8 times 4 is 32. 9 times 4 is 36. 4 will go into 37 9 times. So I write a 9 directly above the 7 that I brought down. 9 times 4 is 36. And then I subtract. 37 minus 36 is 1. Notice that the 9 in the answer is written just to the right of the decimal point because it's written above the 7 that was just to the right of the decimal point inside the long division box. Now, because I'm working with decimal long division here, and because I've moved to the right of the decimal point, I can continue the process. I can extend my long division box. I can write a 0 on the end of the number inside without changing its value. 15.70 is the same as 15.7. Because I'm able to write this 0 on the end, I can bring down that 0 and continue the long division process. Next, I ask myself, how many times does 4 go into 10? 4 goes into 10 twice. I write the 2 above the 0 that I just brought down. 2 times 4 is 8 when I multiply. Then I subtract. 10 minus 8 is 2. And I can continue the process. I can write another 0 on the end. I can bring down that 0, write it next to the 2, and I can ask myself, how many times does 4 go into 20? 4 goes into 25 times. I write a 5 above the 0 that I just brought down. 5 times 4 is 20. And then I subtract. 20 minus 20 is 0. I finally got a 0 when I subtracted, so I can stop the process now. And here we have our answer, 3.925. Now that we have an answer for A, let's go on to problem B, 1.452 divided by 24. Let's set up our long division box for that one. Now, inside the long division box goes the 1.452. 1 I write in a space. My decimal point I place right on one of my red lines. 4, 5, 2. And out in front goes 24. So let's go ahead and start our sequence of 4 steps that we repeat over and over again. But actually, before we start the long division process, let's take a look at the decimal point. The decimal point here in our problem is right between the 1 and the 4, and my answer, the decimal point will end up directly above that same position. Now, let's go ahead and get started. So for divide into, I ask myself, how many times does 24 go into 1? Now, 24 doesn't go into 1 even one time. In fact, it goes in 0 times. Some people like to write a 0 up above in this position. That 0 is optional. It's not required. But if you like to put the 0 there, it's fine to do it. You can decide whether you prefer to write it or not. Next, I need to look at the 1 and the 4 together. I temporarily ignore the decimal point. I just think of this as 24 into 14. Well, 24 doesn't go into 14 either. In fact, it just goes in 0 times. So I write a 0 above the 4. This 0 is absolutely required. Once I get to the right of the decimal point, to this side of the decimal point, if the number in front does not go in, I need to write a 0 up above. So this 0 to the right of the decimal point is required. Well, let's keep going here. Now I'm going to look at 145, again temporarily ignoring the decimal point. How many times does 24 go into 145? Well, let's see, 145 is kind of large. Not really sure how many times 24 would go into that. When I'm not sure, I take the number in front. Sometimes what I do is I just multiply by 5. I see what 5 times that number is to help me get my bearings. 5 times 4 is 20, write the 0, carry the 2. 5 times 2 is 10, plus 2 is 12, so I get 120. Well, 120 is quite a bit smaller than 145. I think I better try 6 times also. 24 times 6. 6 times 4 is 24. Write the 4, carry the 2. 6 times 2 is 12. Plus 2 is 14. I get 144. 144 is just less than 145, so I can see that will work. 24 goes into 145 6 times. I write the 6 above the 5 because that's the last digit that I'm going to use here. 6 times 24 is 144, and I subtract. 145 minus 144. 5 minus 4 is 1. 4 minus 4 is 0. 1 minus 1 is 0. I have just 1 left after I subtract. Next, after the subtract step, I bring down the next digit. So I bring down this 2, and I ask myself, how many times does 24 go into 12? Now, every time you bring down a digit, you need to write a number up above. I brought down that 2 to get 12. 24 goes into 12 0 times, so I need to write a 0 up above. This 0 is also required in our answer. Now, 0 times 24 is 0 when I multiply. 12 minus 0 is 12. I subtract. Then I'm back to a bring down step. Now, I don't have any more digits written inside the long division box, but because I'm to the right of the decimal point, I can write a 0 on the end and bring that 0 down. I now have 120. How many times does 24 go into 120? Well, let's look at what we already figured out here. Well, look at that. We already figured out that 24 times 5 is 120. So 24 goes in exactly 5 times. I write a 5 above the 0 that I just brought down. 5 times 24 is 120. 120 minus 120 is 0. And now, because I got 0 remainder, we're finished. Our answer here is 0.0605. I've written down our answer for B 2 different ways. The answer that we got was 0.0605. Because that 0 in front of the decimal point is optional, you can also write the answer as just 0.0605. Let's go ahead and do problem C now. 56 divided by 32. Here we have one whole number divided by another. This looks like whole number long division. Let's see where it takes us. Now, inside the long division box goes the 56. Out front goes the 32. Notice that this division problem involves 2 whole numbers. In problems A and B, we had decimals involved. What we're going to see here is that even with whole number division, we can introduce a decimal point and use decimals to help us complete the long division process. So let's go ahead and begin the process here. I'm going to begin working with the whole numbers here because the 32 out in front, while it doesn't go into 5 by itself, it does go into 56. Now, how many times does 32 go into 56? It goes at least once. 2 times 32 is 64. That's too big. So I know 32 goes into 56 one time. And I write the 1 above the 6 in the 56. 1 times 32 is 32. And I subtract. 6 minus 2 is 4. 5 minus 3 is 2. Now, if we only knew about whole numbers, if we knew nothing about decimals, we would use 24 as our remainder. But because we're now working with decimals, here's what I can do. I can rewrite my whole number 56 as 56 point. 56 point is the same as the whole number 56. A whole number always has a decimal point understood to be just to the right of the ones place. That means in my answer, I'll also have a decimal point just up above the decimal point that I just wrote. Because I've introduced a decimal point, I can now extend my long division box and write a 0 inside on the end. 56.0 is equal to the whole number 56. It looks a little bit different, but it's exactly the same number. Because I've introduced a decimal point here, zeros on the end do not change the value of the number inside long division. By writing 56.0, I can now bring down that 0, and I can continue the long division process. Of course, notice while I wrote a decimal point inside the long division box, I also had to write a decimal point up above in the answer. Now let's continue. How many times does 32 go into 240? And that I'm not sure about. Let's see, we could try 5 again here. Try 32 times 5. When I'm not sure how many times a number goes in, I often like to just multiply the number in front by 5 and see where that takes me. 5 times 2 is 10, write the 0, carry the 1. 5 times 3 is 15, plus 1 is 16. 160, that's quite a bit too small. I need a larger number than 5. Let's jump to 7. Try 32 times 7. 7 times 2 is 14. Write the 4, carry the 1. 7 times 3 is 21. Plus 1 is 22. I get 224. That's pretty close to 240. 32 times 8, I believe, will be too big. That's going to be quite a bit bigger than 224. So let's go with 7. In fact, 32 times 8 will be bigger than 240. So I write my 7 up above the 0 I brought down. 7 times 32 is 224. We just figured that out. And then I have to subtract here. Now 0, take away 4 I can't do, so I'll borrow. Change the 4 to a 3, 0 to a 10. 10 minus 4 is 6. 3 minus 2 is 1. 2 minus 2 is 0. And you know, if I had any doubts about whether this 7 was large enough, or if I should have used an 8 there, I now know I'm okay, because I subtracted and I got a number smaller than the 32 out front. Because this is smaller than 32, I know 7 was good enough, and I'm certain there's no way 8 could have worked. Now, I've already added one 0 on the end. I can add another 0, and I can bring that 0 down. So I now have 160, and I ask myself, how many times does 32 go into 160? Well, we can benefit from what we've already figured out here. I already figured out that 32 times 5 is 160. So we know 32 goes in exactly 5 times. Write that 5 above the 0 I brought down. 5 times 32 is 160. Subtract 160 minus 160 is 0. When you subtract and get 0, the long division process is over. So we have our answer here, 1.75. Here's our answer for C, 1.75. We got one more to go. Let's go ahead and get to work on D, our last problem in this group, 0.2 divided by 30. So I'll set up my long division box. And inside here goes the 0.2. When we write division this way, the first number always goes inside the long division box. So that's 0.2 inside divided by 30 out front. So let's get started by placing our decimal point in the answer, right above the decimal point that's inside the long division box. We start out the long division process by asking ourselves, how many times does 30 go into that 0 in front? Well, 30 goes into 0 0 times. This 0 just to the left of the decimal point is optional. You don't need to write it. Now let's ask ourselves, how many times does 30 go into 2? 30 goes into 2 0 times, so I write a 0 just to the right of the decimal point. This 0 to the right of the decimal point is absolutely required. Once we move to the right of the decimal point, we have to indicate zeros when they occur up above. Now, I've gotten to 2 here, but I want to continue the long division process. Because I'm to the right of the decimal point inside, I can add a 0 inside and think of this as 20 and ask myself, how many times does 30 go into 20? Well, 30 goes into 20 0 times, doesn't even go once. So here's another one of these required zeros. Am I ever going to get anywhere here? Well, I'm to the right of the decimal point, so I can add another 0 on and ask myself, how many times does 30 go into? Now I'm looking at 200. The 0 in front does not add to the value of this number here. It's just the 200 that I'm looking at. Now, how many times does 30 go into 200? Let's play around with this a little bit. If I take 30 times 5, in fact, 30 times 5, you should be able to do in your head. 3 times 5 is 15, so 30 times 5 is 150. Or if you work it out, 5 times 0 is 0, 3 times 5 is 15. Well, I can see 150 is less than 200. Can I do better than that? Can I do 30 times 6? 30 times 6, again, I hope you can do that in your head. 6 times 0 is 0, 6 times 3 is 18. That's 180. That's really just 3 times 6 with an extra 0 on the end. Now 180 is pretty close to 200. What about 30 times 7? Is that going to be smaller or bigger than 200? I'm going to get 7 times 0 is 0, 3 times 7, 21, 210. That takes me over. So I can see 6 is what I need here. I'm going to write the 6 above this last 0 that I just added on. Notice how crucial these zeros are in between the decimal point and the 6. 6 times 30 now is 180. And I subtract 200 minus 180. 0 minus 0 is 0. 0 take away 8 I can't do, so I got to borrow. 2 becomes 1. 0 becomes 10. 10 minus 8 is 2. 1 minus 1 is 0. So now I get 20 after I subtract. I can add another 0 on and continue this long division process. Bring it down. Ask myself, how many times does 30 go into 200? Well, that's what we just did, right? We know 30 goes into 200 6 times. 6 times 30 is 180 again. 200 minus 180, when I subtract, is going to be 20 again. This process is starting to repeat itself over and over again. In fact, I can see that even if I add another 0 and bring it down, that gives me 200. 30 is going to go into 200 just 6 times again. 6 times 30 is 180. 200 minus 180 is 20. This process is never going to end. It's going to repeat 6, 6, 6, 6, on and on forever. And I'm going to indicate that in my answer by writing ... on the end. So we can write our answer here as 0.00666 with 3 dots. The 3 dots indicates that that pattern repeats. There's also another way to write the answer that's often used in math courses when you have a repeating decimal like this. We still write 0.006, but instead of repeating the 6's, we write a line or a bar on top of the 6. That bar is an indication that that 6 should repeat over and over. So here we now have our answer for our problem D. I've written the answer a couple of different ways. 0.00666 ... would be acceptable. The 0 to the left of the decimal point is optional, so you can leave that 0 off. The 2 zeros to the right are absolutely required. And if you want, you can use this fancier mathematical notation where instead of writing the 6's over and over, you write this line on top of the 6, the bar, to represent the fact that those 6's repeat over and over.